Says problem, resolve the following fractions into partial fractions: x cube plus x square plus 1 by x minus 1 into x cube minus 1. Our motive is, for the given function we need to find out the partial fractions as a by some g of x plus b by some h of x plus and so on. We need to find out these partial fractions. If the denominator is a irreducible function, we can reduce it into smaller fractions and then we can write the partial fractions. Now I want to investigate the problem. Given thing is x cube plus x square plus 1 by x minus 1 into x cube minus 1. So this function can be reducible to another fraction like x cube plus x square plus 1 divided by x minus 1 into x minus 1 into x square plus x plus 1, because this is like a cube minus b cube. I am writing the expansion. So if you see x minus 1 and x minus 1, two similar functions are there, so I can write the fraction like x cube plus x square plus 1 divided by x minus 1 whole square into x square plus x plus 1. This can be written as a by x minus 1 plus b by x minus 1 whole square plus cx plus d by x square plus x plus 1. These are the assumed partial fractions. We need to resolve it. Now I want to resolve the problem. On RHS side I am taking LCM, so I will get x minus 1 whole square into x square plus x plus 1 in the denominator, and in numerator I will get a into x minus 1 into x square plus x plus 1, which can be similar to x cube minus 1 plus b into x square plus x plus 1 plus cx plus d into x minus 1 whole square. Since the denominator on both sides are equal, I am equating the numerators as x cube plus x square plus 1 is equal to ax cube minus a plus bx square plus bx plus b plus cx plus d into x square minus 2x plus 1. Still I can expand, that is equal to ax cube minus a plus bx square plus bx plus b plus cx cube minus 2cx square plus cx plus dx square minus 2dx plus d. So I have some similar terms on both sides, so I want to compare those terms. On LHS side I have 1x cube, so I can write 1 is equal to, on RHS side ax cube and cx cube terms are there, so I'll get a plus c. Let it be equation 1. And I want to compare x square terms. On LHS side I have only one x square term, and on RHS side I have bx square, 2cx square and dx square. So I can write like 1 is equal to b minus 2c plus d. Let it be equation 2. Now I want to compare the x terms. There is no x term on LHS side, but we have x terms on RHS side, that is bx and cx and d 2dx. So b plus c minus 2d is equal to 0. Let it be equation 3. Now I want to compare the constant terms. On LHS side I have 1 is equal to minus a plus b and plus d. Let it be equation 4. Now I want to eliminate some terms so that I can get the values of a, b, c and d. Now I want to subtract equation 2 from equation 4. Minus a plus b plus d is equal to 1. b minus 2c plus d is equal to 1. If I subtract, the sign will changes like this. So plus d minus d plus b minus b gets cancelled. So you will be with minus a plus 2c is equal to 0. That implies a is equal to 2c. Now if you substitute this value in equation 1, 1 is equal to a is 2c plus c. So that implies 3c is equal to 1, c is equal to 1 by 3. If you substitute this c value in the same first equation, I will get 1 is equal to a plus c. So 1 is equal to a plus 1 by 3, or a is equal to 1 minus 1 by 3, that is equal to 2 by 3. I got a value. Now if you substitute these c and a values in equations 3 and 4, you will get three another equations as b minus 2d is equal to, the c will become minus c over there, so you will get 1 minus 1 by 3. And in fourth equation, if you substitute a value as 2 by 3, you will get b plus d is equal to, a is 2 by 3, there it is minus a, it is minus a, so it will become 1 plus 2 by 3. Now if you subtract these equations, you will get minus minus and minus here, plus b and minus b gets cancelled. You will have minus 3d, which is equal to minus 1 by 3 minus 5 by 3. From this I can write minus 3d is equal to minus 6 by 3, or d is equal to 2 by 3. If we substitute this d value in the above resolved equations, you will get b plus d is equal to 5 by 3. So b plus 2 by 3 is equal to 5 by 3. So b is equal to 5 by 3 minus 2 by 3, which is equal to 3 by 3, that is 1. So b value is equal to 1. We have a, b, c and d values. So we can write the partial fraction as x cube plus x square plus 1 by x minus 1 into x cube minus 1 is equal to 2 by 3 into x minus 1 plus 1 by x minus 1 whole square plus x plus 2 by 3 into x square plus x plus 1.